Something that is important to know is that a system of linear equations is equivalent to an equation in which we have one matrix, the matrix of the coefficients in the equations. Look at the coefficients here. 2, 4, minus 5 are the entries of the first row. The coefficients in the second equations are the entries in the second row of the matrix. And the coefficients in the third equation here are the entries of the third row of the equations. So this matrix multiplied by the vector of unknowns is equal to the vector of constant that are at the other side of the equal signs. So to know that the system of these three equations is equivalent to just one equation is very important, because that gives me a way to solve a system of equations in just one step. So solving this equation is equivalent to solving this system of equations. For example, if we have these two equations, minus 2x plus ay equal 14 and 6x minus ay equal negative 18, this will be equivalent to a matrix equation in which the matrix of the coefficients minus 2a 6a, let's type it here, minus 2a 6 minus a, multiplying the vector of unknowns x, y, just verify that the unknowns are in the same order in both equations, x and y, and this will be equal to a vector of the constant, the vector of the number that appears at the other side of the equations. So these two equations is equivalent just to this one equation. The system could be a big system. If we have a system of equations and if we verify that the unknowns are in the same order in all of the equation, this system of several linear equations can be considered equivalent to a matrix equation in which we have only one factor, that will be the matrix of the coefficients that we have here, multiplying by a vector of all the unknowns, and that will be equal to the vector of constants at the other side. So in general, every system of linear equations can be considered equivalent to just one equation. And what I'm going to explain today is how to solve this system of linear equations in just one step. So let's explain this. Let's study the situation in which we have the same number of equations as the number of unknowns. So in this case we have n equations with n unknowns. And we know also that this system of linear equation is actually equivalent to a matrix equation in which we have here the matrix of the coefficients, a vector of the unknowns equal to a vector of the constant. If we have this, then actually what we have is just one equation of this form. A, the matrix of the coefficients, multiplied by x, that is the unknown, is actually a vector of unknowns equal to a vector of constant. And solving this equation, in case that a is invertible, so in case that the determinant of a is different than 0, so we can say that we have an inverse. So if a is a non-singular matrix, then we can multiply by the inverse of a both sides of the equation. So multiplying by the inverse of a, what we are going to obtain is the inverse of a multiplied by x is equal to the inverse of a multiplying b. And obviously, because the multiplication in matrix is an associative operation, we can just multiply the inverse of a multiplied by a. That will produce the identity. So that actually will be the identity multiplied by x equal the inverse of a multiplying b. And the identity multiplied by x is just x. So x equal the inverse of a multiplying b. So this will be a formula that we should use, that we are going to use to solve the equation. And of course, this will be a formula that will be easy to implement in a computer if we have the adequate software. So in Excel, for example, you can compute the inverse of the matrix A and multiply it by B. Here I will show you how to use R for solving a problem like this. If we have a question like this, a system of equations, we know that this system of equations will be equivalent to a matrix equation in which the matrix A will be the matrix of coefficients. And this multiplied by the vector of unknowns will give you the vector of constant that appears at the other side of the equal sign. So the solution will be the vector of unknowns equal to the inverse of the matrix, that is the matrix of coefficients, multiplying by the vector of. If this inverse exists, then we are going to have a solution of the system, and the first value in the vector we get will be the value of the first unknown, the second value will be the value of the second unknown, and the third value in the vector of the result will be the third unknown. So the value appears in the same order that the unknowns are given. So let's see how to use R to solve a problem like this. So we have that the solution is this, and we have R. So for using R, first thing to do in this case is called Pracma, the package that will be useful for solving problems related to a matrix algebra. So call library, open bracket, and open quotations also. So Pracma need to be written in quotations and in bracket. And after that, the formula I know that I'm going to use will be x equal the inverse of A multiplied by B. So I will need to enter A and B in Pracma. So after you press enter, then you type the matrix. Yeah. First, let's type the matrix A. So it will be A matrix, and remember combination of the columns. And after you get the combination of the column, type the number of row and number of columns. So again, combination of columns: 2, 4, 1, 4, 3, negative 3, minus 5, 10, negative 15. So that will be the way that you need to enter the matrix in R. So you type matrix, that will be the command for entering the matrix. C, a command for combinations of columns, and then the columns 2, 4, 1, the second column 4, 3, negative 3, minus 5, 10, negative 15. All of them separated by comma. Then a comma for separate the number of rows and then the number of columns of this matrix. If you don't type this, R is not going to understand how many rows, how many columns. If you have 9 elements, so 9 elements can be combined in several ways. Yes? You can type 9 rows, only 1 column, or maybe 1 column, 9 rows, or maybe 3 columns, 3 rows, in 3 ways. So for R to understand that will be this matrix, you need to type number of rows, number of columns. And you can type this semicolon to type the other matrix, and the other matrix is B, this 7, 5, 1. So let's type B equal matrix, and then obviously the combination will be of only 1 column, 7, 5, 1, and then in this case will be 3 rows, 1 column. So after you press this, press enter. So if you press enter, R is ready for you to enter whatever command you want. And you want to know what was x. So just type the formula. X equal the inverse of A multiplied by B. Remember that the multiplication signs for matrix will be enclosed in percent signs. So you type x equal inverse A multiplied B. The inverse of A multiplied B. So look at the multiplication signs, the multiplication of matrices in R. Be careful. The percent, the multiplication, and again percent. So the multiplication signs will be enclosed in these 2 percent signs. That means multiplication of matrices. So the inverse of A you are going to multiply by b and press enter. Now R knows the result. Know the result of the vector x, so the vector of unknowns. If you want to see the solution, just type x and enter. Just type x and then press enter. And R will give you the answer. 1, 1 minus 0.2. So that will be the vector. And that means that the first unknown is 1. The second unknown is 1 also. And the third, x to 3, will be minus 0.2. So let's type this. x1 equal 1, x2 equal 1, and x3 equal minus 0.2. You can give the answer in this way, or you can say row vector 1, 1 minus 0.2. That is the solution of this problem. This is a way of solving a system of linear equations. When the system have a unique solution, it means when the inverse of Ax, the determinant of the matrix, is different than 0. In other cases, that doesn't work because we cannot compute the inverse of A. So for that cases, it will be better to use a reduced row echelon form of the augmented matrix. So in another video, I will be explaining how to use Pracma for solving a system of linear equation, even if the inverse of A doesn't exist. But for that video, that will be okay. So let's stop here. I hope you have found it useful. Thank you.